What's up, everybody? I'm Abnormal FPV, and I recently got my Part 107 license right before Christmas, and I'm excited to be building this B35 CineWhoop. It's my first CineWhoop, and hopefully getting some jobs with it. So I've got everything laid out here. We're going to go through hopefully a quick build process. It's going to be split into 2 videos, but to start I'm going to unbox everything and we'll do some soldering and then we'll move forward. So I got the B35 frame, a Radiomaster RP1 receiver. It's an ELRS receiver. And let's see. Of course, I've got an XT60 connector because the flight controller I have came with an XT30. And the smoke stopper, I've never used a smoke stopper before. Just a multimeter, so we'll give that a try. And here's the stack. I've got a SpeedyBee F405 20x20 stack. It's a 35 amp, which, by the way, 35 amps means per motor, not total. So each motor could go up to 35 amps. Anyway, then I got the DJI O3 Air Unit. I know the O4 dropped, but these are cheaper now, and the storage on the O4 Lite is 23 gigabytes. That's not good enough for me. So I wanted to have removable storage, so I got this one. Also to note, it's my first DJI product, so it's going to be a learning experience for both of us. And let's see, the motors here, I've got some Xing by iFlight. They're 2205, 2300 kilovolt motors. They're for 6S. So here they are. They're a little pancakey, but I think they're going to work nicely. I really like the iFlight motors. That's what I've been getting lately. And while I'm kind of moseying around here, I'd like to add, if you want to buy any of these products, I am newly affiliated with GetFPV. I'll put a link in the description, so if you want to go buy any, stuff for your own builds, I would really appreciate any support using that link. So, alright, in the SpeedyBee 35 Pro box, I've got some parts that I supplied, but I will put those to the side and show you what came with the drone frame and everything, and then we'll get into building. So I've got the strap and the antenna backpack, which also holds a GPS, and a pretty neat feature, which I'll show you in just a minute. There's the GoPro mount, and let's see what's next here. There we go. There's the GPS holder tray thing. It's kind of small, so I might make my own. And then here's a bunch of little TPU parts. This ring goes on the antenna holder, and then these little fins are for a crossfire antenna. I won't be using the fins, but I do need the ring. This little superhero mask is what holds the O3 Air Unit into the heatsink. I printed my own antenna holder and my own O3 holder. Okay, and here are the cool little cables that will go into the antenna backpack. They extend your flight controller's USB, so you don't have to open it up every time to connect. See, as you can see here, I've already installed it in the purple TPU backpack that I'm going to put on there, and yeah, I'm pretty excited to try it out. Here's the prop guards. They feel pretty durable. Never used any of those before, so we'll see how tuning and everything goes. There are the camera dampeners. There's 2 for 20mm and 19mm, and there's the carbon fiber frame and the battery plate. And let's see. I think the last thing is the camera plate here. Oh, there's some hardware, of course, the GoPro mount hardware. Lots of hardware, and the camera plate. So besides that, it's just hardware in the box. And oh, I'm sorry, I completely forgot the cool feature of this, the heatsink for the O3. So there's the heatsink and a little CNC cover for that. That'll allow us to get to the O3 and keep it cool too. And here's the hardware for the heatsink. And here is the rest of the hardware. And they certainly didn't skimp out. We got plenty of hardware. There's at least one extra of just about everything. Plus they also include different size stack mounting screws and all sorts of hardware specific to the frame, of course. There's some that you need instead of like the stack mounting screws. You want to use those instead. You may want to use the motor screws. So anyway, let's move forward with this build here. I think what I'm going to do is put the cam plate together just because that's what the instructions say. But to be honest, I'm going to put the cam plate down and I'm not going to touch it until I'm ready to button everything up pretty much. That's just because the O3 goes in last, so I don't really see why it's that necessary to install this now. But that's up to you. You want to follow the instructions, then please do. The cam plate's pretty simple. I think it's just got some M2 screws on either side and then a standoff in the center. And then of course the camera dampeners, but don't bother putting those in until you're ready to put the camera in, or they'll probably just fall out. Definitely thanks to SpeedyBee for labeling everything so nice. Had a couple frames that just have a singular bag full of screws and little tiny nuts and washers and stuff for you to figure out. So I appreciate not making it any harder than it has to be. And as you can see, I'm putting the cam plate together here, and once I get that other screw in and tighten it down just a smidge, and it's done. Alright, let's clean up this stuff and we'll get moving forward here. I think I'm going to put the stack in first and the motors, and then we'll solder that on, do all the soldering on the frame, and then we'll start putting everything together. So what we'll need for that, since this is a 20x20, uses M2 screws, we'll need all the M2 stack mounts for the frame. And like I said earlier, you want to use these frame specific ones because they have a different chamfer at the head. It's made so that they can fit inside the recesses in the frame and fit flush. So yeah, I recommend using those. I'm sure you could probably use the other ones, but this is what's designed for the frame, and I'd rather not break anything building it for the first time. This seems kind of silly. So what I like to do is I like to use the motor screws from the motors if they fit, and that's because they typically come with Loctite, and they're typically like the screws from iFlight are top quality. I've gotten some that just shred like cheese when you put the hex driver in there, and these are good. You can tell when you're locked in and when you're not. So I'd rather use the iFlight screws if they fit, and I'm going to check that right here, make sure that they don't touch the motor windings. So if they do, then I will use the other screws, or if they get close, I'm not going to just screw it all the way in and destroy the motor, but I'll give you a little hint. These are going to work just fine. And my other hint for this is when you're putting the motors on for the first time, do yourself a favor and don't do what I'm about to do. Just put 2 screws in. For some reason, I put all 4 in all 4 motors, and then I had to take them all out and put them back in several times. So yeah, just do 2. You'll be fine with 2. The whole reason that we're putting the motors into the frame, here they are, is because you can get the perfect length of your motor wires. So I'm gonna just eyeball it and kind of figure out how I want to route the wires. then we'll worry about cutting and preparing everything. So here is the stuff inside the stack box. It's got an XT30 connector, capacitor, HD video connector, and two different types of grommets, M2 and M3, and the screws for those, and nylon nuts, and silicone washers, everything, okay? So, alright, so we're going to heat up the iron and get everything going here. Make sure you've got lots of flux. I like this flux. I don't really even know if it's brand, worthy, but it works. And I cut my own wires. I used 12 AWG so that I can make an XT60 connector. And these are a little bit long, but okay, yeah, the pliers here, I've got a hair tie around, and I'm going to use that to hold the connector in. It's pretty handy if you don't have helping hands. Honestly, it works great in the field. So just look at your connector. You can see at the bottom, usually, or on the sides, what the polarity is. It'll show you a positive and a negative symbol. So just make sure you're aware of where you're soldering the wires to, and you'll be good. So I left this beginning part in here because I made a mistake with the XT60 connector and ended up melting it. So you'll see me melt it, and I'll show you here, and then I'll show you a trick on how not to melt it in the future. They're kind of easy to melt if you're doing a good thorough job soldering, because you want to have solder inside those terminal wells, not completely full, but you do want to have enough that when you put the wire in, that it has contact all the way around and it's very secure. So first we're going to add flux to the terminals. It's pretty important to get a good amount in there because, like I said, this is going to fill up with solder. It's more than, you'll need more than you think, but you don't want to overdo it, so be careful. And of course you need shrink tubing if you're going to make connectors, just to keep it neat. So let's start with some tinning and move forward from there. My soldering iron went to sleep on me, so sorry about that. Give it a sec. Alright, she's ready to rock. If you're interested in any soldering tutorials, I do have a soldering tutorial video. I will try to make a card and put that in the video here. But for now, we'll move forward with the tinning. Let's tin the wires, and then we'll worry about the connector. Oh, what I always like to say to people that are asking about soldering is, first of all, to tin your wire first, so make sure you strip it and then add the solder to the wire. These big wires really needed extra solder added to the tip first because they're so large. It wasn't conducting heat well, and then once you get that going, you can add the solder right to the wire like I'm doing here. That'll give you a perfect tin, and then you can trim that. It'll all stay in a neat bundle, and your soldering will be super clean. Alright, just get a little bit more, and that should be good. Now time to do the XT60 connector. Like I mentioned earlier, I am going to ruin this connector. Okay? If you want to see me ruin this connector, keep watching. Because it's pretty easy to do. It's pretty easy to avoid if you remember the trick I will show you. But it happens. get some extra connectors, practice. Not every time comes out perfect. So as you can see, I'm heating as much surface area on the terminal as I can. Then I'm going to add some solder to the tip and try to get that to touch the wall a little bit. And once it touches the wall, you can just keep adding it to that blob of solder and fill up the terminal below the line where it like scallops off. So if you fill it a little bit below that line when you put your wire in, it will fill the rest of the terminal up for you. So here we go. Here comes the melting. Yeah, my iron is set a little hot for this right now, and I stayed on a little too long, and there it went. It melted right down, pushed it right towards the table. So I'm going to turn the iron down just a smidge, and we're going to get a new connector, but I'll show you what happened here, if you can see it anyway. Aurix. Sorry about that, I was messing around with the temperature trying to get that set back up. So here's what happened to the connector. As you can see, it pushed right in there, so that's no good. So I'm going to grab a new connector, and here's my fancy trick for you. You get a male and a female connector and plug them together. Boop! Now you've got yourself a heat sink. And it won't push in even if you melted it just a little bit. So this is the recommended method for every single XT30 connector that I do. And I typically don't need it for the 60s, but just to be safe this time I'm going to do it anyway. And as you can see, it's going to go nice and smooth. So yeah, just if you have a male and a female connector to use, I would highly recommend just doing that off the start. So let's tin these terminals back up and get on with the build. I keep taking the iron off and putting it back on just to try to get it to flow a little bit further down. To put some heat maybe lower on the terminal, and there we go. That's looking pretty good. I don't think it needs too much more, so let us move to the next one. And the advantage of these pliers holding the connector is you can just move it anywhere you want on the table. I know helping hands work the same way, but this is pretty sturdy. So let's do that treble connector. Treble side, my unlucky side. And here's a final reminder to make sure you get wow, I can't talk. Make sure you get the polarity correct as you're finishing up this part, because nobody wants to plug in a connector the correct way and you solder the wires in backwards and you still fry your stuff, especially on a brand new build. As you can see, I heated up the terminal, and I'm putting the wire in as it's still hot, and then melting the solder on the wire and heating the terminal at the same time. So you kind of have to make sure you're on both parts of it. Once you get the heat on everything, it'll all melt together. Leave it for a second and let it cool, and you'll have a good joint. So one side is done. Let's hit the positive side now and finally move forward. Connector building shouldn't take this long. Well, alright. There it is. Good to go. Well, while we have some downtime, I'll mention this is my first build video. This is the first time I'm really ever showing anybody building at all or talking about it. So if you have any tips or any suggestions, please comment, subscribe, let me know what you'd like to see next or how I could make this better for you, and I will build another one. For now, I'm going to grab out the shrink tubing, and we'll put that on. This XT60 connector does have the protective cover that slips on and clips and covers the solder joints, but this makes it look a little neater and holds it into the connector, into the clip a little better. If you don't have the clip, that's fine, just use the shrink tubing. But make sure that your solder joints are cooled completely, or that the shrink tube will shrink before you can get it seated fully onto the terminals there. You want to kind of twist it over the top of the terminals and seat the shrink tube into the connector, into the connector a little. And yep, heat it up and shrink them, and then we'll put the little protective clip on. I don't really like to use a lighter most of the time. It works, but potential for error is much higher. I do have a heat gun, I'll use that next time. Okay, so here's the clip. All you do is wiggle it down over the connection there and then press it into place. And there it is. Good to go. Okay, the next thing we need to do here is get this capacitor onto the flight controller. So if you look at the side of the capacitor, it should have a negative symbol, or if it doesn't, the negative side should be the shorter leg. So just make sure you get the polarity right. Then also double check that to your flight controller. So what I'm going to do is trim the legs. We're going to bend them. I'll probably bend them first, then trim it, and then go ahead and put it into the flight controller and kind of like tin the pads so it stays in place. Then we'll put the wires on for the battery lead. So I'm not doing any measuring here. I'm thinking a 90-degree bend is going to work nicely, so I'm just kind of going to eyeball it to see how much room I actually need to give it. And since this B35 is pretty tight inside, I'm going to put it directly in the middle of the two wires. So here we go. I'll give it our nice little 90 bend. Okay. Looks pretty good to me. Something I noticed here was I trimmed the legs before I put them in, and it kind of smushed the metal a little bit and made it harder to fit into those tiny little holes. It might be better to trim it after if you can do that carefully, but it still worked fine, so I think you'll be alright either way. What I had to do here was try to re-crimp like that smushed portion a little bit with the pliers, and it ended up fitting in fine anyway. Yeah, as you can see, I'm struggling a little because one of those is just not wanting to go in the hole there. So here we go. We'll crimp it up and it should fit. There we go. So I just used this little Creality scraper to hold this cap in place, but whatever you have is fine. And as always, flux, tin, and then we'll put those wires on after we trim them. There we go, there's the positive. Here's the negative. It's a little cumbersome the way I chose to do this, so if you don't need to, don't do it. You know, put the cap on in an easy way. And then give it a continuity check. You'll get a beep still, but just a short one, if it's good. And then we'll put the the ESC back into the frame and get to work on the motors. Okay, we're looking good. So I'm going to figure out how I want to route these. Sometimes it's neater to route them around the stack screws and then keep it all inside the stack, you know, having, you know, the solder joints this way. But I think I'm going to go just directly to the directly to the pads. So as you can see, I trimmed so they'd all fit, and then stripped here, and then we'll tin again and do this process all over again 3 more times. I find it easier to work across my body from left to right, or across the drone from left to right, because I'm right-handed. So it makes it easier to not work over solder joints you've already done, potentially screwing them up or whatever. You can kind of just go in a line. I'm still figuring this out for, you know, this build, so I'm not going to do that on this side, but you'll see on the next side that it will go much simpler. I'm still working left to right here, but I kind of chose to face it towards me to make sure I can see everything a little bit better. There we go, there's one motor. Just do all of them the same way. Take your time. If you screw up the soldering, just realize when you're, you know, making a mistake and when to stop, and then you can fix that. You know, use your copper wick or solder sucker or something to fix the damage before it becomes unrepairable. So as you can see on this side, I've got it figured out now. So it's going to go nice and fast. Alright, so since this side is the same as the other, I will move forward a little because I kind of skipped through the next step you know, in the video. I didn't skip it, but we fast forwarded. So anyway, what you want to do is perform a nice continuity check on every solder joint you do. Make sure you have a multimeter. That's why I haven't used the smoke stopper yet, because I trust the multimeter more. So get out that and check it against the ground. Check all your motors, check against the adjacent joints, and you should be good to go. That's the end of part 1. We'll see you in the next segment.